Good afternoon, everyone, and welcome to today's GCSE Maths live group tutorial. Today's is on percentages, and this is part one. So there will be another session on percentages tomorrow. So if you'd like to join us for that, then please do. It's lovely to see so many of you joining us for this session. So welcome back if you've been joining Molly for her GCSE Maths sessions over the past couple of weeks. And welcome if this is your first time. I'll just give a quick overview. So today's session will be 1 hour long as normal, so we'll be finishing around 1:15. And today's session is GCSE Maths, and it's run by Molly, who studies computer science and mathematics at the University of Bath. And she's one of our top tutors at My Tutor. She's completed over 150 lessons. So today's session should be a really good one, and hopefully really useful for you guys. And as I said, it's been split into 2 sessions, so join us for the next one tomorrow. You can ask questions throughout. There's the chat function and the Q&A, so you can ask Molly any questions about anything she's going through, or you can ask me anything about the My Tutor online school. I'm Tilly, I work at My Tutor. So if you have any questions for either of us, please ask those throughout the session. And then after Molly's gone through the content, then we'll have some time for questions at the end, whatever those may be. So if we're ready to kick off, Molly?
Yeah. Cool.
Brilliant.
Hello everybody, I'm Molly. And today I look very red because I've been for a run, because I'm an idiot. Right, okay, so as Tilly said, today is going to be on percentages, and this is part 1. So just as an overview of kind of both of the days, today is going to be more of the kind of base level stuff that you need. So calculating percentages, so you know what's 58% of 10 or whatever, and the other way around, so saying like what is 70 out of 80 as a percentage, and then also we'll come to a little bit of percentage increase and decrease, and then tomorrow we're going to look at reverse percentages, compound interest, and some harder word questions. So that's the breakdown, just to let you know. But everything today we'll be using again tomorrow. So today is a really good like fundamentals of percentages and stuff like that. So let me grab my pen, which I've put on the other side of the desk, helpfully. So yeah, we'll start off by talking about how to calculate a percentage of something. So there are a couple of methods, what I would kind of call the non-calculator method and the calculator method. And I'll go through both with you. So sometimes we'll get something kind of like this. Let's go for something. So say 36% of 280. And I'm going to show you both methods of this. So the calculator method only takes 1 line. Obviously, if this is in a non-calculator exam, then you can't do that. So the non-calculator method is probably the one that you're familiar with. So non-calc, probably. I don't know. You probably know both, to be honest. If not, we'll learn something. So what we do here is we calculate percentages that we know we can calculate. And normally this is broken down into 10%, 1% in general. So, for example, 10% of 280, that's just dividing by 10. Because 100% is the whole thing. So 10% is a tenth of it. So 10% will be 28. That's good. It's not 36%, but it's a start. We can kind of see that this 36% here, we're going to need 3 of them to make it up to 30%. And then this 6%, well, we can think of that as, we can either think of it as 6 lots of 1% or a 5% and a 1%. Hopefully this makes sense once you do it. So here's what I'll do. So 10% is that. So 30% is 3 lots of that. So that's going to be 84. 5% is half of this first one. So it's 14. 5% is just half of 10%, right? We've just divided that by 2. And then 1%, we divide this by 100. So instead of, we knock off the 0 and we put a decimal point here. So it's 2.8. And then what we do is we see, well, 36% therefore, it's the weirdest percentage sign I've ever drawn, is these three, 30%, a 5%, a 1%. So we add all of these three together. And that's going to give us 100.8, I think. I'm going to check that. I have a calculator today so that I can check things like that. 84 plus 14 plus 2.8, yeah, 100.8. So that's how we calculate it that way. Hopefully that makes sense. Yeah, brilliant. People were getting that really well. Nice. So now, obviously, that took a few steps. We did that all, I mean, I checked it on the calculator, but I did that all, without using a calculator. Now, if we want to do that much quicker, if this is in a calculator paper or maybe part of a calculator question, like a longer answer question, what we're going to do is find something magic called the multiplier of this. And what that basically means is this divided by 100 in this case. But when we get to percentage increase and decrease, the multipliers will be slightly different. So the multiplier in this case is 0.36. Hopefully you can see where that's come from. So the multiplier of 5% is 0.05. The multiplier of 70% is 0.7. Hopefully you can see where those are coming from. So then all we do is 0.36 times 280. And we pop that into our calculator and we'll get 100.8. So that's obviously kind of a much easier method, but harder to do in your head. So hopefully those two methods make sense. Just shout if either of them don't. Someone said on the Q&A, why do you have a new background? Because I'm downstairs today rather than upstairs. Mental. Yeah, so we'll have a look at another couple like that. So let's have a look at 58% of 74. So we'll do it both ways again. Even the non-calculator is going to be quite difficult this time. Someone said, did I social distance on my run? Of course I did. So let's do it both of the methods again. So we'll do our non-calculator method here. So what we can do nicely here is straight away calculate 50%. That's quite easy. 50% of something is half of it. So we can say 50% equals half of 74, which is 37. I'm good at maths, I promise. That is right, isn't it? Yeah. And then we want to find this remaining 8%. So we can do that in several ways. Try to work out what's the best. Probably just calculating 1% and timesing it by 8. That's something that we can do. It's quite an intuitive one that we can do. So let's have a look at 1%, which is going to be equal to 0.74. Remember, I've divided it by 100, so I put a decimal point here, 2 places in. And then times that by 8, which you could do using column multiplication. I'm not, because we've just seen how great my mental maths is. If anybody wants me to go through the column multiplication for that, let me know. So 5.92, that will give you. And then we see that 58% is this and this. So 58% is going to be equal to 42.92. Yeah, perfect. Well done, guys. And then our other method, which is much quicker, we see that our multiplier is 0.58, and we times that by our 74. And that will also give us 42.92. So if you have a calculator, use the multiplier method. Look how much time that saves, and there's so much less room for error. Okay. Someone did come up with another good method, which I will go through actually for non-calculator ones, just to give you as many methods as possible, is that this is kind of combining the two. So this 0.58 can also be written as 58 over 100, right? Because 100 is the whole thing, and we want 58% of that 100%. So it's like doing this times 74, which is like saying 58 over 100 times 74 over 1. And then we can simplify this multiplication. For example, dividing both of these by 2 gives us 50 here and 37 here. It's still quite a lot of multiplication, but it's another way that you can do it if that way makes more sense for you. Cool. Perfect. Yeah, we can also write this as a fraction. We can write this as 50 over 100 and do that in our calculator. It's easier to type decimals in your calculator, that's all. And it also becomes easier when we're doing increase and decrease. Okay, let's have a look at, I'll go through calculating a percentage of something. Basically, I'll go through all of the topics and then we'll go through, I've got lots of word questions ready, just because I think the word questions are quite a mix. So this way is the other way around, how to calculate what percentage of something a number is. So for example, the main thing I always think about is like exam results. So you get a test back and you get 20 out of 45, you might want to know what that is as a percentage. Let's do that one as an example. So 20 out of 45. Now this is super easy. It's much easier to do with a calculator. And to be honest, most percentage questions are going to be calculator questions. So I'll kind of assume that from now on. I'll just show you briefly in a moment how you would do something like this without a calculator. In fact, I'll start by doing that just to show you. So the point is that we have 20 out of 45. This is how we're going to write it. This is like the fraction, basically. And we want this to read as something out of 100, because then the top number's the percentage, right? We have 30 out of 100, that's 30%. So if we can make this be something out of 100, ideal. So I would, if you're doing it non-calculator, break it down to a factor of 100 and then scale it up. I'm probably making it more confusing than it needs to be, but basically just hopefully through this example, it'll make sense. So I'm going to make the denominator here 5. So I've divided by 9. So then the top is like 20 over 9. I know that's a fraction within a fraction. Disgusting, but it's okay. And then to make the denominator 100, we're multiplying by 20. So this becomes 400 over 9. So then that's what the percentage is. And you just, these are horrible numbers to do non-calculator, but this would be the answer, is 400 divided by 9%, whatever that may be. I'll do a nicer example in a moment that you can do on a calculator. In fact, typically the next one I have written down works quite nicely. But if we're doing this with a calculator, we write that same thing. So it is a fraction. And then to make it a percentage, all we have to do is times it by 100. Yeah, perfect. So it's going to give us, I think, 44.4. So these ones that I'm doing at the moment, these are foundation level. They'll also be in higher papers, but this is foundation level. Once I get to percentage increase and decrease, it's going to be more like higher. And then tomorrow's lesson will be mostly higher level stuff. Mostly. Still worth coming to if you're doing foundation. But so yeah, this will give us 44.44. That's rounded to 2. This is recurring percent. So that was a horrible example to do non-calculator, but hopefully that method makes sense. As you can see, again, when we have a calculator, we can do it really quickly. So I'll do another one. So let's say we have 54 as a percentage of 90. Let's look at our 2 methods again. So our non-calculator method, we write 54 out of 90, and we want this denominator to be 100. So what I'm going to do is I can see that I can make this denominator 10 if I divide it by 9. So I can say that this equals something over 10, and 54 divided by 9 is 6. So 54 divided by 90 is the same as 6 divided by 10. This, if we multiply the top and the bottom by 10, is the same as 60 out of 100. And now, because we have something out of 100, it's this percent. So we get 60%. Now, if we want to do our calculator method, we just take 54 over 90 and multiply it by 100, and we'll get 60. So hopefully that will make sense. With percentages, if the answer that you get is recurring, they'll normally tell you what to round it to. I'd normally round it to 2 decimal places if they don't tell you. Someone said, where did the 9 come from? I guess you mean here. That was just that I spotted that to make this 90 into a 100, like without a calculator, I could divide it by 9 to get 10 and then multiply by 10. It's just kind of spotting what you can do to this. Normally you want to divide this to make this number either like 1 or 5 or 10 or 50, something that you can then scale up to 100. This is less common. Like you'll normally just be able to do this method, but it's good to show you because they might throw something sneaky like that in. How are we doing for time? Oh, way ahead of the game. Nice. So hopefully that makes sense. Okay. I'll just do, I'm not going to do one more example because I think people are getting that, and I'll come back to it when we do that. Yeah, so someone's asked what will happen to the multiplier when you're doing a percentage increase or decrease. That's what I'm going to go through now. So I'm going to spend a bit longer on this because it's a bit of a trickier one. But you'll probably be used to questions that are like, a car is this value, it decreases by 20%, how much is it after a year? Or a dress is in a sale in a shop on a sale of 20%, how much is it after the sale? And so on. So that's what we use this for. And there's a really, really nice way to literally work these types of questions out in one line just by playing around with the multiplier. So let's say that we have something like this. So a car is worth £3,300 and the value goes down by 10%. What is it worth now? Right, so this is a fairly standard question. And there are a couple of ways that we can do it. Perhaps the most intuitive way is to work out 10% and take it off. But there's a nicer thing that we can do. So how I think of it is kind of if we are taking 10% away, we're left with 90%, right? My favorite example of a cake, if we have a cake, 100% of a cake, and I give 10% of it to my mum, I'm left with 90% of the cake, right? So that means instead of subtracting 10%, we can calculate 90% of this. The other way to think about that is to think the kind of straight method way is to think, well, what's the multiplier for 10%? It's 0.1. And it's a percentage decrease. We want to decrease by this number. So our multiplier is going to be 1 minus 0.1, which is 0.9, which you can also see as 90%, like that percentage that we're left with. So what we do is we take our multiplier, 0.9, and times that by 3,330. So this is just our one line of working out to work out this whole question. And we will get 2,970. So let me just check if people are getting that. Somebody said, where did you get the 0.1 from? That's from the 10%. That's what the multiplier is for 10%. We're dividing it by 100. Yeah. Cool. Okay. What I'm going to do is get some questions up from here. Oh, that's giving it answer. Increase. That's quite useful. I'll come to those in a moment. Yeah, okay, we'll go through these to work out both. We'll just basically tackle some word questions for a while now. So, 2 parts to this question. First one here, part A. Hopefully that's big enough. The price of a TV is £260. in the sale, the price is decreased by 20%. Work out the price of the TV in the sale. So what we're going to do is work out our multiplier. Hopefully you can see that our multiplier for 20% is 0.2. So because we're doing a percentage decrease, we want to use 0.8, right? 0.2 less than 1. And then we multiply that by our 260. And we will get, times 260, 208. Which I think a lot of you were getting, which is really good. Okay, so hopefully that will make sense. That's just kind of what we were doing before, and hopefully it makes sense with the multiplier as well, because this is a really nice, quick way of doing it just in one line, which can save you a lot of time. Okay, let's have a look at part B here. This is a kind of the opposite of this. So this is saying that the number of TVs sold increased, and now we want to calculate the percentage increase. So we're kind of having to calculate the other thing here. There are a couple of ways to do this. I'll show you both. So the first way, I'll scroll down so that you can just see this question. The first way is to do, we'll work out how much it increased by, 28, right? To get from 70 to 98, we're increasing by 28. Increase of 28. And then we work out that 28 as a percentage of the original number. So 28 as a percentage of 70. And if you remember from what we were doing before, that's 28 out of 70 times 100. And that will give us 40. So this is a 40% increase. Hopefully that method makes sense. Cool. The other way that we can do this is think about it in terms of the method that we just used. So we can think, well, we've taken 70, we've multiplied it by some multiplier, we'll call it X, and that's given us 98. So what's our multiplier going to be? Well, we do 98 divided by 70, right? So all I'm doing is just, normally our questions, we're given these two and we want to work out this. But here I'm saying, well, what is the multiplier that we've used to get from 70 to 98? Well, to work that out, we do 98 divided by 70, which is going to give us 1.4. And now this is something that I haven't quite covered yet, but you might know or have guessed that when we do a percentage increase, we add it to 1. So if this was a 40% decrease, our multiplier would be 0.6, but it's a 40% increase, so it's 1.4. So we can see that this multiplier directly translates to plus 40%. So those are the two methods. They're quite different, so just whichever one works best. Out of interest, which method do people prefer? We'll call this first one A and the second one B. Oh, quite a range. That's interesting. I'll try doing them with both from now on. I think most say A, but a few say B. Cool. Someone asked where I got the 28 from. That was from the difference, so 98 minus 70. Because there's 28 more, so what is that? It's a percentage of 70. Cool. From now on, if I have questions like this, I'll try to show you both methods. Because I think that's best. Cool. Okay, so let's go over some more word questions. Oh gosh, every time I go up to the top bar drops down. Let me move it out of the way. Okay, that's better. Yeah, let's do this one, and we'll do it in both ways again. So, the value of a painting rises from 120,000 to 192,000. Work out the percentage increase in the value of the painting. So we'll do it in both ways. I'll do it in method B first this time. So we're saying that we've got a painting that is 120,000 and we're timesing it by some multiplier, and we're ending up with 192,000. So what was our multiplier? Well, our multiplier will then be 192,000 over 120,000, which is going to, that was a horrible equal sign, gosh, which was 192,000, 120,000, 1.6. And hopefully you can see that this directly translates to a 60% increase. Hopefully that one makes sense. Yeah, that. And then this other method here, well, how much has it risen by? To get from 120,000 to 192,000, we're increasing it by 72,000. So we take that, work out what that is as a percentage of our original amount. So to do that, we do that and times it by 100, and that will give us 60. So it's, yeah, the same thing that we get using both methods. Hopefully that all makes sense there. Okay, let's have a look at one like this quickly, where we have a percentage decrease. So here we have Peter's weight decreases from 80 kilograms to 64 kilograms. Calculate the percentage decrease in Peter's weight. So again, I'll do both methods. I'll do method A first this time. So this time it's ever so slightly different. I mean, it's very similar, but we're going to do what's the decrease and do that as a percentage of the original amount. So he's lost 16 kilograms. So we do 16 out of 80 and times that by 100 to get our percentage. So that's going to be 20%. Or using method B, we see, well, we've got 80, we've times it by some multiplier, and we've gotten out 64. So x is going to be 64 divided by 80, and that's 0.8. And we can see that this multiplier directly translates to minus 20%. So it's quite interesting to see that method with a decrease, right? You get out 0.8, be careful, it's not 80%, it's 20%. So the percentage decrease was 20%. Check the chat. Yeah, I think pretty much everybody got that. Brilliant. Okay, fab. Somebody said, what if the percentage is over 100%? That's a really good point. So let's have a look at one like that. So let's say a business has £300 and they make 250% of that next year. And we want to know how much they make. There are a couple of ways of kind of doing this and thinking about it. The first kind of immediate way that I would think about it is saying, well, 250, well, 100% is 1 times it, right? So if they made 100% next year, they would again have made £300. If they made 200% next year, they'd have made £600. So that's the method that we're thinking about. And what we do is we say that here, the multiplier is going to be 2.5. So if they make 250%, they make 300 times 2.5, which I think is going to be 750. She says not writing 750. So yeah, percentages over 100 are a bit weird because you can't really have more than 100% of something. It's like, you know, if people say, oh, you put in 110% effort, that's not really possible. You know, you can't have more than 100% of what you have. However, in this case, we're using it to mean they made 2.5 times as much. So you can, if I have a cake and my brother has 200% of the cake that I have, it means that he has twice as much cake. So it's usually used in like business to say, oh, we made 300% profit on this. And it just means you made 3 times. Hopefully that makes sense as to how you can have it. Okay, let's go back and have a look at some more questions. Let's try to find some harder ones. Okay, let's just have a look at this one. I'm wary about going into the content for tomorrow, so I don't want to start doing compound interest or reverse percentages yet. I'd rather make sure that everyone's 100% happy with it. Because, I mean, hopefully, this sounds like a weird thing to hope for in a lesson, right? Hopefully, this will get quite boring, but it should be boring because it's so easy and you can like do it every time, right? You can just see it, you know what the multiplier is, you know how to work it out. And that will mean that trickier topics, trickier questions that we'll do tomorrow, we'll reach some level 8, level 9 questions tomorrow. Hopefully those will feel a lot easier because you've got such a solid understanding of the basics. So let's have a look at this one. An empty bucket weighs 800 grams and the weight of the bucket increases to 2.1 kilograms when filled with water. Calculate the percentage increase in the weight of the bucket. And here it says give your answer to 2 significant figures. So it's either going to be recurring or quite a long decimal, perhaps. First thing to notice here that examiners love doing is a unit conversion. They love it because it's an extra step, it's an extra place where they can catch you out. So with percentages, you've got to make sure everything is in the same unit. Otherwise, you're going to get some weird answers out. Because if we assume that these are the same units, then what we're really calculating is 800 grams decreasing to 2.1 grams, and it all just gets a bit weird. So hopefully you can see that this is 2,100 grams. So that's the very first thing we're going to do. Even before we've read the question, I would see that and go, ooh, unit conversion. And now we can go ahead and do our usual percentage increase. So I'll do both methods again. I'll start with method B this time. So we're taking 800, we're timesing it by some multiplier to get out 2,100. So what's our multiplier going to be? Well, it's going to be 2,100 divided by 800, which is going to be 2.625. Oh, look at this. I chose a question and it happens to be one that's greater than 100. Perfect. So this you've got to be really careful with because if this was 1.625, we'd know it would be a 62.5% increase. But actually, because it's 2.625, right, we've added whatever the multiplier is onto 1. So our multiplier is going to be 1.625, which means that it's a 162.5% increase, which to 2 significant figures is 160%. Hopefully that makes sense. I did that. Then if we do our other method, method A, well, let's look at the difference. How much did it increase by? Well, it increased by 1,300. So now this is where you've got to be really careful because this will feel very strange. We do 1,300 as a percentage of 800. Now you'll probably see this and shiver a bit because you've got a percentage that you're working out, but the numerator is bigger than the denominator. What? And all that means is that you're going to get out a percentage that is bigger than 100. And you can kind of see this here because this is way more than twice this. So you know it's got to be more than 100% increase. So we work out this. And this will give us, if we do this calculation, multiply it by 100, this will give us 162.5, which we know, these, by the way, mean roughly equal to, so this is because I'm rounding it to 2 significant figures, 160% increase. And that means that you take 160% and you add it on. It can be quite easy to get confused between 160% of something and a 160% increase. So just be careful with that. Did I get the amount wrong? 1,300. No, it is 1,300. How is that two significant figures? This is a keynote on the difference, between significant figures and decimal places. So significant figures means that you find the first non-zero. So in our case, it's here, it's this 1, and then you count 2 figures, so 1, 6, and then you round it at this point. Hopefully that makes sense. Okay, cool. Let's do one more. Let's have a look at this one, because we've got some horrible decimal points here, which nobody likes. Okay. Orla weighed 3.77 kilograms when she was born. On her second birthday, she weighed 12.8 kilograms. Calculate the percentage increase in her weight. So again, I mean, just looking at this, you can see that it's going to be bigger than 100% because it's many times bigger, you know, so it's going to be 300% or something. And it's a percentage increase. So it's not a percentage of this, it's a plus something. So we're going to do it both methods. This time I'll start with method A. We'll calculate. Now this is a little bit harder to see, so we might need to calculate it. What's the difference in her weight? It's 12.8 minus 3.77, which is 9.03. So she's gotten 9.03 kilograms heavier. So we want to work out that as a percentage of her original weight. So we do that increase divided by the original weight and times it by 100 to work out the percentage. And that's going to give us, I'm just going to do this to 2 decimal places, 239.52. So this is a plus 239.52%. Okay, and then using method B, we've got 3.77. We're timesing it by some multiplier to get to 12.8. What's our multiplier? It's going to be 12.8 divided by 3.77. So our multiplier is 12.8 divided by 3.77. It's 3.3952. And remember, that translates to an increase in 239.52, because if you need to, subtract 1 from it, basically. And hopefully that makes sense, because say if we had like an increase of 50%, that would be a multiplier of 1.5. If we had an increase of 150%, that would be a multiplier of 2.5. So this directly translates to plus 239.52%. So we get the same thing each time. Hopefully that makes sense. Don't worry if you only understand one of these methods, you only need to understand one. Somebody said, why do you always use cake as an example? I don't know, I like cake. Clearly I'm hungry. And some people have asked about percentage decrease. So we'll go through that now. And I assume you mean a percentage decrease where it's bigger than like 100%. So these can be, these can get a bit strange. So let's say we have like, it's normally again in like business terms. So £500 suffer a percentage decrease of, 215%. So they have that £500 and they have a decrease of 250%. What on earth does that mean? So we're going to work out our multiplier first of all. So our straight multiplier for 215% is 2.15, because 100% is a multiplier of 1. We're scaling it to that. Now, because it's a decrease, remember, we take it away from 1. So this is where it gets a little bit strange. So we're doing 1 minus 2.15 to get our multiplier for this question. So that's going to give us minus 1.15. So now to work out the question, we're going to take our multiplier and we're going to times it by our amount of money. And that's going to give us 500 times minus 575. So what this company has done is they've actually made a loss in the next year and they've lost £575. That would be quite a rare question to get, but you've just got to bear in mind that it's the same. It's exactly the same process, just with weirder numbers. You do the same thing. You work out the multiplier. It's a decrease, so you take it off 1 and you multiply it. Hopefully that makes sense. Somebody asked what's the hardest percentage question you can get. Those ones will be going over tomorrow. The hardest ones are probably, I don't know. I mean, these are quite difficult, I think, when they're bigger than 100%. The hardest ones are probably reverse percentages, compound interest, maybe a combination of the two. So tune in tomorrow for some of those. And this session ends at 1:15. Someone said, why do you take it off 1 and not 100? It's because we're taking the multiplier. So this 1 kind of does represent 100, but we're taking off the multiplier. If you ever get confused with this, think what you would do if it wasn't 100%. So like if it was 20% decrease, that would be a multiplier of 0.8, right? You're taking off that. And people have asked for more questions like this, so I'll do that. What I'll do is we've got 3 minutes before questions, so I'm going to do one that's calculating a percentage decrease when it's more than 100%, and then one where it's calculating what the percentage decrease is. So we'll start off by saying, let's say we have 290. What is a percentage decrease of 376%, right? I'm making it a horrible one so that you can see. In fact, no, I'm not going to make it even worse. 376%. So we want to take this number and we want to know what happens if we decrease that number by 376%. Just a quick note to hopefully make this understandable. If you were to decrease this by 100%, it would become 0, right? Because 100% of it is that 290. So if you decrease it by that, it becomes 0. So we know that we're obviously going to get something less than 0. So let's work out, first of all, our multiplier for 376%. That's 3.76, right? This 3 kind of represents that it's 376%. So then what's our multiplier for this question? Well, it's a decrease. So we subtract it from 1. So that gives us minus 2 point, oh gosh, now I'm doubting everything. Can she do maths? We'll never know. Okay, 1 minus 3.76 minus 2.76. I thought so. I had a crisis, you know. Okay, so we take this as our multiplier for this question, and we just do what we normally do. We take our multiplier, we times it by our amount, and we'll get our solution, which is going to be 290 minus 800.4. Yeah, people are getting that. Cool, well done. Okay, I've kind of reached time for questions, so if people want me to go over more like this, just shout. If not, yeah, I'll answer questions.
Yeah, cool. There haven't been all that many general questions throughout, so just put some questions in the chat, and I'll just make sure that things have been answered. Let's have a look. Yeah, brilliant. A few people saying go through some more. So if you have any questions generally on other things, or if I have to have missed any of your questions, just put them in the chat whilst Molly goes through another one or two, and then we can have some questions at the end. Is that okay, Molly?
Yeah, that's cool. I'll go through some like this now.
Great.
What I'll do first of all is I'll go through a one where you have to find the percentage decrease. For example, let's say, let me type this one. So a company made £450 this year. Last year. This year they lost £750. What is this as a percentage decrease? So again, we can apply both of our methods, A and B, to this. So the key thing to note is that this is 450 and this is minus 750. So how much money did they lose? Well, they lost 450 minus 750. That makes sense. That's how much money they lost. So that's 1,200. And we want to calculate that as a percentage of our original amount. So that's what we're going to do. And that gives us 266.67. So I'm rounding it. It's 6 recurring, so I'm just rounding it to 2 decimal places. So it's a minus 266.67% decrease. Using our method B, we say, well, we've gone from 450 by some multiplier to minus 750. So what on earth was our multiplier? Well, we do minus 750 divided by 450, which gives us minus 1.67. And then we know that that was subtracted from 1 because it's a decrease. So we add it back onto the 1. That makes sense. So this will translate to well, I really should have done this to more decimal places here. Oops. To get it to the same. And then this translates to a minus 266.67%. I'd say method A is probably easier for percentages greater than 100 in these cases. These are as hard as it gets in terms of just these straight calculating percentage increase and decrease. And I'll just do one more where you have to calculate a percentage increase. For example, one where it's like, let's say a zoo has 100, let's make it more interesting than that, 120 monkeys. The following year, they have 610 monkeys. What is the percentage increase in monkeys? Because I come up with these questions on the spot, they're normally horrible, like recurring percentages, like that last one, or weird ones. The questions that I've pre-made are nice, but these ones aren't always nice. So this is the same thing. We're just calculating what the increase is here, and it's just going to be a bigger number, basically. Oh, this wasn't the type of question I meant to do at all, but I'm going to do it anyway, and maybe come to another one. I meant to do a percentage increase of something. So let's look at method B first. We're going from 120 by some multiplier to 610. So what's our multiplier? It's 610 divided by 120, which is 5. Oh, see, it's a horrible number again. 5.083, and that 3 is recurring. And we see that this is going to translate to a plus So our multiplier would have been added to 1, so it's actually 4.083, which is plus 408.3%. And we can probably see that a bit more clearly here. If we're going from 120 to 610 monkeys, that's 490 more monkeys. 490 more monkeys. So what's that as a percentage of our original amount of monkeys? Well, that's this calculation, which gives us, just double checking that I've done everything right. Yeah, which gives us straight away oh my gosh, what did I do there? I switched the tab, mental, right, which gives us straight away 408.3%. So hopefully that makes sense there. Awesome. The question that I meant to do, which I'll do quickly because I think we have time, was one more like this. So let's say on Monday there were 200 bacteria in a petri dish. Oh my god, I did not spell that right. I probably didn't spell that right either, but oh well. And by today, that amount has increased by 375%. How many bacteria are there today? So this is what I meant to do, was like they give you a percentage. So what we do is we work out our multiplier. So 375 is 3.75. And now because it's an increase, this is a bit easier. We're adding it to 1. So it's 1 plus 3.75 is 4.75, our multiplier for this one. So we take our multiplier and we times it by the original amount of bacteria. So we get 4.75 times 200. And this gives us 950. Hopefully that makes sense. You've just got to remember that they're like exactly the same kind of thing. Oh, some people there, just to point out, a few people said 750. That is really good. You were using this multiplier, but you were using this one. So that's how many it increased by. You've then got to add it to the 200 again, which is essentially what we're doing by increasing the multiplier by 1. So if you got 750, you're totally along the right lines. So yeah, are there any more questions?
We had a question about tomorrow's percentages session. Will we do percentages with 2 stages tomorrow?
Oh yeah, sure, we definitely can do. It's not in the plan, but it will be now. So I assume you mean, correct me if I'm wrong, like 20% of this and then 70% or something. I assume that's what you mean, so yes, I can definitely put that in the plan.
Cool, and someone's asked, what is the difference between method A and B?
Let me find one where I've done them both and I'll show you. So for example here, method A, we're working out the actual increase as a percentage, whereas this method, we're kind of working backwards and thinking about it in terms of our multiplier. It's quite difficult to explain what the difference is. They're quite different methods. So in method A, we're thinking about how much we have actually increased and what's that as a percentage. And in the second method, we're kind of thinking, what have we used as our multiplier to get between these two numbers? Hopefully that makes sense.
Cool, and someone asked, this may have been answered earlier, but what's the hardest type of percentage question you can get?
That's really difficult to answer. I think it's probably reverse percentages or compound, the kind of stuff that I'm doing tomorrow. What I'll do is I'll do some research before tomorrow and try to find the hardest that I can do.
Brilliant. You guys want a challenge. I like it. So just a couple of questions quickly that have come through about the online school. Some people asking, will you be doing French, ICT, a few different subjects? We are definitely planning on adding more subjects, but the full programme hasn't been decided yet because this is still new. And yeah, we've only been running the online school for a couple of weeks. So thanks so much for the suggestions, really useful. We're keeping an eye on that and we'll let you know during these seminars, webinars, and during and on the online school page. So just keep an eye there, and we'll let you know. And someone else asking, when will Key Stage 3 come? Equally, I can't give you an exact date that it's coming, but it's coming hopefully soon, and we'll keep you guys updated here and by email as well. Then a couple of people also joined a little bit late to the tutorial and sort of asked what they'd missed, and if we could go through some of the earlier stuff. Just a reminder, and also if you haven't joined us before, just to let you know, these tutorials are all recorded, so if you miss anything or you want to just watch back to give yourself a refresher at any point, you can watch all of these back on the My Tutor YouTube channel. So just type in My Tutor into YouTube, you can find all these past recordings, and also in all the other subjects as well. So if you haven't joined us for any of those, we're also doing English and the 3 sciences at the moment, and in fact we've got a science session at 2 p.m. which is GCSE Physics. So if you'd like to join us for that, then please do. We've got another couple of minutes if you guys have any further questions. Molly, do you think that's good for content today?
Yeah, there's just one question that I wanted to answer that someone's put, is that where did the 408.3 come from here? So I'll just briefly explain that. That's because this is the multiplier that we used. So if we were thinking kind of in the other direction, if our question was a zoo has 120 monkeys and the next year they have an increase of 408.3%, the multiplier that we would use is this. We're like working backwards and thinking, well, what percentage would we use to get this multiplier? And because it's an increase, whatever it is, we've added it to 1. So it's going to be 4.083. And then we know that that represents 400. Hopefully that makes sense. Does that answer the question? I hope so. Yeah, are there any others today?
I think we just had through when rounding recurring decimals, do we write roughly equals or equals?
Good question. Normally roughly equals, I would say. So I guess with this, maybe I should have said, roughly equals. Yeah, and in fact here, I should have put roughly equals. I don't think you would ever get docked marks for it. But it kind of helps you as well if you're coming back to it, to remember that that's what it was that you were doing. So I'd normally put roughly equals, but it doesn't matter too much.
Cool. And someone asked about the biology session. We don't actually have a biology session today. We have one tomorrow, and that will be on transport systems. But what we've got this afternoon is GCSE Physics, and that's on reflection and refraction. And you can find the link to that on the site, and also on any emails you've received. And you just join it the same way you joined this. Let's have a look. In percentage questions, would there be questions like higher or lower than, Molly?
I don't really know what that question means. I saw that. No, there'll be questions like higher than or lower than. If you could whoever asked that, could you rephrase that question? Because I don't really understand it.
Brilliant, thank you. And let's have a look. And a few questions sort of more generally about the online school and sort of schooling at the moment for you guys, obviously with school closures. Unfortunately, we don't really have the information on that. So what I recommend you do is just have a little research on the internet about school closures and what that means for your guys' exams. But this online school is here to sort of keep you guys learning, keep you up to date with all the content of your GCSEs. So definitely carry on attending the tutorials, and hopefully you're finding them like really valuable. That person that asked the question, Molly, just said, can you see that message? Yeah,
15% greater than 55%. I still don't fully get what you mean, like what kind of a question that would be. So I don't think so. But yeah, I'm not 100% sure what you mean. I'm really sorry. If you kind of mean, is 15% of this greater than 55% of this? Or do you just mean is like 15% greater than 55%? Because I feel like that's quite an obvious kind of one. I'm not 100% sure about what you mean. I'm sorry. So I don't think that that's applicable.
Cool. And what I think we'll do is wrap up there. Thanks so much for all the questions, guys. That was a really nice interactive lesson, and you can watch it back, as I said. Please do join us. Please do join us tomorrow for percentages part 2 at the same time. So thanks for joining us, and hopefully see all you guys in another session soon. And thanks very much, Molly, for today's session.
Yeah, cool. Thank you, everybody. Hope it made sense, and see you tomorrow.
Have a good afternoon. Bye.